Hello, welcome back. We are now going ahead with more and more trigonometry. The first bit which I'm going to do today, what they call product and sum formulae. In the Excel syllabus, it's called extension of ideas, but I've seen it in OCR and perhaps AQA too. So I'll just do it, and it's a pretty interesting concept, and it helps you learn to think and reason out. So we are still in topic 5. We're still in trigonometry. Sum and product formula. Sum to product, product to sum. Let's, instead of saying 2, we can as well say sum and product formula or the factor formula. Instead of writing that, we can put it as factor formula. To understand this, the formula for sine of A plus B and so on. Let's write this. Sine of A plus B plus sine of A minus B. What would that be? Would be sine A cos B plus cos A sin B minus plus sin A cos B minus cos A sin B. Yeah? So when you add them, the cos A sin B's cancel. So I can write it as 2 sin A cos B. So can I say 2 sin A cos B equals sine of A plus B plus sine of A minus B. Alright? What happens now if this is a minus? Then that becomes a minus, that becomes a plus. I get 2 cos A sin B. So 2 cos A sin B equal to sine of A plus B minus sine of A minus B. Alright? We have done the signs. Let's do, look, I told you, unfortunately, we'll go to 10. We'll do sine and cos. What you do for sine, you do for cos. So what's cos? Oh, by the way, my name is Sosale Mohana. I teach A-level maths. I taught A-level maths for a long time, over 50 years, and I'm now using these lessons to help you revise A-level pure maths. Welcome. So cos of A plus B plus cos of A minus B. I don't have to, you could figure out yourself. This is cos A cos B plus minus sin A sin B plus cos A cos B plus sin A sin B. Sin A sin B will cancel. So I can say 2 cos A cos B equal to cos of A plus B plus cos of A minus B. The other one is a bit difficult. What is that? That would be cos A cos B minus sin A sin B minus cos A cos B minus sin A sin B. Now these two cancel. I get minus 2 sin A sin B. Yeah? So that's the change there. So 2 sin A sin B, or can I do it the other way? I can keep it as minus 2 sin A sin B. Okay, let's do that first. Equal to cos of A plus B minus cos of A minus B. But I can multiply through by minus and switch it and say 2 sin A sin B only for sine, they get interchanged. It becomes cos of A minus B minus cos of A plus B. Okay? Now, where are these formulae useful? At the moment, they're not useful. But when you do integration, suppose you have to integrate sine 4x cos 7x dx, use this formula. You can do integration, otherwise you have to do integration by parts twice and then group everything. Instead of doing that, you could use this formula. So people who are doing integration by parts or integration under trig, I will revisit this. But I have a purpose of taking this. Look, this is a product, and then the product is being expressed as a sum. So these are the product to sum formulae. But for a moment, let's assume let A plus B be equal to P. I'm using the same letters as in your formula book. These formulae you don't have to remember, you can deduce them from the formula book. And A minus B equals Q. I want to find what is A in terms of P and Q, what is B in terms of P and Q. What happens when you add? When you add 2A equals P plus Q, or A equal to P plus Q over 2. When you subtract, 2B is equal to P minus Q, B equal to P minus Q over 2. Now, this opens up a whole new set of formulae, where should I write? I think this formula is too far away, so I'll put the formula here, and then I will write on top there. Write it the other way. So in place of A plus B, I can write P. In place of A minus B, I can write Q. In place of A, I can write P plus Q over 2. In place of B, I can write P minus Q over 2. So I can say sine P plus sine Q equal to 2 sine P plus Q over 2 cos P minus Q over 2. This is in your formula book. Sine P minus sine Q equal to 2 cos P plus Q over 2 sine P minus Q over 2. Cos P minus cos Q equal to 2 cos P plus Q over 2 cos P minus Q over 2. But the last one is going to be slightly different, so I'll put it in blue. So what is, that's a plus, sorry. So what's cos P minus cos Q? Will be minus 2 sine, right? So it is minus 2 sine P plus Q over 2 sine P minus Q over 2. I would rather remember it this way. Some books say sine of Q minus P over 2, interchanging the negative. But I don't want to. Look here. This one was a sum, so these are called sum to product formula. The whole lot of them are called factor formulae. I mean, the examiners are well within their remit. If they ask you, show that sine of P plus sine of Q equals 2 sine P plus Q over 2 cos P minus Q over 2, where P is A plus B, Q is A minus B. Then you have to find sine of A plus B, sine of A minus B, find that formula and convert it. Okay? I'm not saying they're going to ask, but they are well within their rights to ask. Now this is where the questions become very, very, very interesting. I think the board is getting smudged. I need to get some liquid fluid to clean the board. I'll do it next time. You can't use water because these are chemical pens, you see. Alright. For example, they can be used in identities. Remember I told you, any new formula we use questions, we use identities, we use equations. New set of formulae, new questions. So now let me see if I can get some questions. Not before identities, let's simplify. Simplify. Let me take the first example. Let's say cos 5x minus cos 2x. Cos P minus cos Q. Yeah. P is 5x, Q is 2x, so it is minus 2 sine P plus Q over 2 sine P minus Q over 2. So that will become minus 2 sine 5 plus 2, 7x over 2 sine 3x over 2. Well, what is the use of knowing this? How fine. You got a plus and you convert it, or a minus and you convert it into a product, sum to a product. So what? Suppose this was equal to 0. Then you can't solve that. You don't know the formula for cos 5x. Yeah, there is one way out. You can assume 2x to the principal value, but that requires a different kind of thinking. But to avoid that, you could use this formula. Now I can equate sine 7x over 2 equal to 0 and solve. I can equate sine 3x over 2 equal to 0 and solve. Isn't it? So the reason why a particular formula has been found is to see where you can apply them and how. For example, you have to integrate. Yeah, well, sorry, I don't want to take that because you will say, sir, what is this integration you're talking about? You haven't even taught us anything about calculus. Why are you going there? So let's leave it at that. Suppose I had simplify 2 cos 30 plus cos 60 plus cos 45. No, that doesn't make sense. Cos 120. Is it going to help? It is in a way. Suppose I have this. Now, what is cos? You can group any two you want. But do you realize what is 120 plus 60? 180. Divided by 2? 90. This will become 0. Sir, suddenly you went off. How do I know it becomes 0? And I'm not supposed to use a calculator. Fine. Write it as cos 30 plus, cos 60 plus cos 120 is 2 cos 120 plus 60 over 2 cos 120 minus 60 over 2. See, this on the assumption that you don't realize cos 120 is minus cos 60. That will be 2 cos 90 cos 30. Cos 90 is 0. So your answer is cos 30. Don't have to use a calculator. Yeah. I'm just taking this example to show you how these questions can help you revise, your techniques of solving trig equations. Identities. Let's look at, as I told you, okay, we'll do some identities. These are not important at the moment, but those are. So, identities. Then why did I write this? So that people doing integration currently, or when I do integration, remember I told you, you're going to make a card. I will refer to the formula in the card. Let's look at the identities. What is sine B plus sine C over cos B minus cos C? What would that be? Equal to minus cot B minus C over 2. Prove. So, as usual, start from the left. Sin B plus sin C is 2 sin B plus C over 2 cos B minus C over 2 over cos B minus cos C is minus 2 sin B plus C over 2 sin B minus C over 2. Haha. The 2's cancel, the sines cancel. I get cos B minus C over 2 divided by sin B minus C over 2 is minus cot B minus C over 2. You proved it, haven't you? Okay. I just made up all these questions. The next one is very important, very interesting. This way, you need to learn how to think. Cos 3x plus cos 5x plus cos 7x equal to cos 5x times 2 cos 2x plus 1. Ooh. Now this is where, you see, that's the beauty of these questions. They make you think, improve your brain capacity and reasoning ability. Look, using this formula, I can group these, I can group these, or I can group those. Which one are you going to group? Do you understand what I'm saying? Look, cos A plus cos B, I can group any two I want. But what you group depends upon what you want. I want cos 5x as a common factor. I have cos 5x here. If these two can give me cos 5x, I can factorize, isn't it? But do they give you cos 5x? The way I want you to remember this formula is add the angles, divide by 2, multiply the angles, subtract the angles, divide by 2. So what is 7x plus 3x? 10x. Divided by 2, 5x. 7x minus 3x, 4x. Divided by 2, 2x. That means by combining these two, I can get both cos 2x and cos 5x. So that's how you combine. So start with the left hand side. You understand the thinking behind. I could have grouped this 5 plus 8, 8 over 2 is 4. There is no common factor with 7. I could group these two, 7 plus 5 is 12, 12 over 2 is 6. There is no cos 6x. But I want cos 5x, 7 plus 3 is 10, 10 over 2 is 5. So you need to analyze and pick which one can you group. So it is cos 7x plus cos 3x plus cos 5x. So that is 2 cos 7x plus 5x over 2 cos 7x minus, 3x. 7x minus 3x over 2 plus cos 5x. Now, I did something, did you notice? Especially if it's a plus, it's easier to write the bigger and then the smaller so that you avoid an unnecessary negative sign. Otherwise, you can write 3x plus 7x, but this will become 3x minus 7x, then you have to use cos of minus theta equals cos theta. So therefore, that becomes 2 cos 5x cos 2x plus cos 5x. I can remove cos 5x as a common factor. I get 2 cos 2x plus 1 equal to, oh sorry, not equal to 0, which is the right hand side. See? So nice, isn't it? The formula can be applied in so many ways, but you pick the one that suits you best. Let me pick another question. This can come very well in your paper because it can be done in so many ways. Sin x minus sin of x plus 120 plus sin of x plus 240 equals 0. I need to prove it. Oh no, oh no, oh no, oh no, oh no. Would that work? Sin 120, sin x, negative, negative, no, no. That should be 60 and that should be 120. Now it should work. Let's see. Start with the left hand side. Now which two are you going to group? You can group, it's easier to group these because the signs, I mean x plus 120, x plus 60, I can simplify. The other way of doing it would be expand sin of x plus 60, expand sin of x plus 120, substitute for cos 60, cos 120, sin 60, sin 120, simplify, show it is 0. But this is much easier as I will show you. Can I write this as sin x minus, no, plus sin of x plus 120 minus sin of x plus 60. Agreed? Okay. So that is sin x plus sin A minus sin B is 2 cos A plus B over 2 sin A minus B over 2. Agreed? Okay. So that is sin x plus 2 times cos of 120 plus 60 is 180. 180 divided by 2 is 90. X plus x, 2x. 2x divided by 2 is x. Times x minus x cancels. 120 minus 60 is 60. 60 divided by 2 is 30. Now, 90 plus x is more than 90, so it's in the second quadrant. In the second quadrant, cos is negative. I got the sign. Now, 90 is 90 times 1. Remember, 90 times odd plus x, sin becomes cos. So, cos becomes sin. So, minus sin x times sin 30 is half. Now, what do you notice? The 2's and cancels. I get 2 and half cancel, so I get sin x minus sin x, which is 0. As I said, if you don't want to, you can use the other way, but do you understand how it's, whereas, why didn't I group x and 120, sin of x plus 120? It would still work, because then I'll get a positive sin of x plus 60, which can be cancelled. But I thought this gives me an opportunity to go over how to find ratios of angles more than 90 once again, because I did about 6 lessons ago, and you might have forgotten. I didn't, built-in memory. But because you haven't practiced enough, you might forget. So I thought every chance I get to go over what was done before, I would do it. Right. I know how much time I have taken. I think I'll just do one more question and stop. Let me take some equation. For example, you're asked to solve something like this. Solve alright, cos x plus sin 2x minus cos 3x equal to 0. Solve for let's say 0 less than or equal to x less than 360. Unless you know the formula for cos 3x, formula for sin 2x is going to be a mess because sin 2x will have 2 sin x cos x. So it's going to be a problem. So the best way would be, of course you can do it, you remove cos 3x as 4 cos cube x minus 3 cos x and then remove cos x as common factor. You'll have a cos squared, cos and a sin. Write cos squared as 1 minus sin squared. You're stuck with the cos there still. So it's not going to help by using formulae, but this will help. I can group this, so can I rewrite this as sin 2x plus cos x minus cos 3x equal to 0? I told you just now, sir, preferably use the other way. Always put the bigger one first. So can I write this as minus open bracket? Can I write it as cos 3x minus cos x? So sin 2x minus cos A minus cos P minus cos Q is minus 2 sin P plus Q over 2 sin P minus Q over 2 equal to 0. So minus and minus becomes plus. So sin 2x plus 2 sin 2x sin x equal to 0. I can remove sin 2x common factor. I get 2 sin x plus 1 equal to 0. You see, by using sum to product, the moment a product is 0, it's easy to solve. So I can say sin 2x equal to 0, sin x equal to minus half. I will leave you to work out all those answers. I'll just write the answer. 2x is 0. So x is 0, x is 90, x is 180 is 90, 360 can't be. So 0 and 90 are the only two values there. And then sin x is minus half, x is 210 and then 330. Those will be your answers. If I'm wrong, you can correct yourself. But I think I'm right. Sin 2x is 0 because x is 0. 0, 180 and 360. 2x is 0, 180, 360. X is 0, 90 and 180. Oh, I'm sorry. There's one more answer. 180. Yeah? Okay? Yeah, because now sin x graph 0, 180, 360. So 2x is 0, 180, 360, x is 0, 90, 180. But is that enough? Have I missed something? I don't draw the 2x graph and do it. So I will go by my previous method. PV is 0, SV is 180. So 2x equal to 360n plus 0, 360n plus 180. So x equal to 180n, 180n plus 90. You see I'm missing one. N is 0, I get 0 and 90. N is 1, I get 180 and 270. N is 2, it becomes 360. So there is one more answer, 270. Of course, I could have done the other way using transformations, but that will confuse you. So I'll stick to the method which I taught you before. Alright, thank you. That is a brief introduction to factor formulae. I'll see you next time. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.